Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
The lingual wire is an orthodontic appliance that consists of two mandibular first permanent molar bands, it also has half-round tube and shaft type attachment of the wire to the lingual surface of the molar band with Loctite wire, various spurs and auxiliary springs. Here is an auxiliary spring that has been attached to the lingual wire. These spurs, as shown here, and auxiliary springs are soldered on to the main wire of the lingual wire, in some cases to contact or move specific teeth on the dental arch. The lingual wire appliance is used clinically for a variety of purposes. It can be a space maintainer to maintain the circumference of a lower dental arch, that is, prevent any lingual movement of the lower dental arch teeth. It also can be used as a space regaining appliance to reposition mandibular molars that have drifted mesially after the premature loss of a primary molar. In this case here, this mandibular right first permanent molar has drifted mesially and has caused the impaction of the second bicuspid that should be erupting into this portion of the dental arch. The second bicuspid on the other side of the arch has erupted. It has become impacted on this side of the arch because of mesial drift and mesial tipping of this first permanent molar. The lingual wire appliance can be used to apply a distal orthodontic force on mesially drifted first permanent molars and thus regain space for the second bicuspid to erupt into the mouth. A third utilization of the lingual wire appliance is as an anchorage base from which auxiliary springs can be attached and from which they can act to move individual teeth along a dental arch. In this example case here, the auxiliary spring could be used to apply a labial force to this first bicuspid tooth. The first step in the actual construction of a lingual wire appliance is to fit bands on the mandibular first permanent molars. While the bands are still in place, an alginate impression of the arch is taken, and after the impression has been taken, the bands are removed from the molars in the mouth, and half-round Mershon tubes are soldered on to the lingual surface of the molar bands. Now, these half-round tubes are soldered in a precise manner. They should be positioned directly in the middle of the tooth, mesiodistally. They should be positioned so that the top or occlusal edge of the half-round tube is 0.02 inches apical to the occlusal edge of the band. The size of the wire that you're going to be using to construct a lingual wire appliance is 0.032 inches in diameter. This 0.032 inch diameter wire then will extend slightly occlusal to the occlusal edge of the band when you have the half-round tube soldered in the proper position. The reason we specify 0.02 inches as the displacement of the tube from the occlusal edge of the band is to prevent the placement of the tube too far to the gingival. We want to avoid, if at all possible, impingement of this half-round tube on the free gingival margin. As it is, it comes very close to impingement in many, many cases. The solder joint joining the half-round tube to the band must be smooth and continuous and free of any surface defects in the solder. After the half-round tubes are soldered on, the impression is prepared by removing a small block of alginate from the buccal and lingual areas of the molar band impression. The alginate is removed right down to the tray metal. The bands are placed in the impression and then sticky waxed directly to the tray metal to secure them in place while this impression is being poured up to construct the work model. The bands are placed in this impression so that their occlusal edge rests on the impression that the occlusal edge made in the alginate. You find the spot where the band feels like it's resting passively on the impression material, and this will give you a sufficiently accurate band orientation for construction of the work model. The impression is poured in white or yellow rapid stone. It's a matter of gently vibrating the stone into the impression to avoid any displacement of the band, any breakage of your sticky wax joint of the band to the impression and the impression tray. The work model is trimmed to remove the base material for convenience. The first step in the work model construction is to form a pencil outline. The pencil outline marks the positioning of the wire as you want to construct it. Now, in the anterior portion, the lingual wire should be bent to contact the teeth just above the free gingival margin. This is from cuspid to cuspid in the anterior region. In the bicuspid region, the wire should contact the lingual surface of the teeth 1 to 2 millimeters occlusal to the free gingival margin, depending on the size of these bicuspid teeth and the size of the dental arch. The adjustment loops for the lingual wire start apically at the distal 1/3 of the second bicuspid tooth. This portion of the loop is about 6 millimeters long. The loop is about 4 millimeters wide, and it should extend up to be about 2 millimeters mesial to the half-round tube when it's properly constructed. To start the construction of the lingual wire itself, a piece of 0.32-inch diameter wire is selected. Approximately a 6-inch long piece is usually sufficient for construction of a lingual wire. And about 6 millimeters from the end of the piece of 0.32 gold wire, a half-round shaft is soldered on. Now, this half-round shaft is soldered so that the shaft is in perfect parallelism with the main body of the wire. It is soldered so that there is a joint of solder between the wire and the shaft itself that is continuous and smooth, free of any surface defects. No solder should be flowed down onto the sides of the half-round shaft, and there should be no grinding or smoothing of any kind on the side of this precision fit half-round shaft. You can grind and smooth the burrs off the end of the half-round shaft, however, to aid its sliding into the half-round tube. To actually start to bend this wire, you should first take a look at the work model from a posterior view. By looking in this area here, you can see that there is an angle between the attached gingiva and the half-round tube. The first loop, in other words, is not going to be directly parallel to the shaft as you bend it to make it fit on the work model. You have to be sure that the loop does not impinge upon tissues at any point. To bend this loop, the wire is placed in the beaks of 139 bird beak pliers. You place the beaks of the plier just mesial to the point where you soldered on the half-round shaft, and you make a right angle bend in the wire, keeping in mind the angle of the attached gingiva to the half-round tube that you observed on your work model. After this portion has been bent, you can measure the length of the distal aspect of this loop with a Bowley gauge. And in that way, determine where you should start making the curve to construct the loop. You can measure on the wire that you've just bent that same length and mark it with a wax wire marking pencil. At the point where you want the loop to start. You place the wire back in the plier beaks and bend this loop in a smooth, continuous motion. It would be better to make the loop too small and then expand it than it would be to make the loop too large to start with. It's easier to correct a loop that has been bent too small than one that has been bent too large. At this point, you can try your wire down into the half-round tube on the work model, and it's apparent that the angulation of this right angle bend is too extreme. So the wire is removed from the work model and an adjustment bend is made. By placing the beaks of the plier back in the original position and with a little thumb pressure, apply a little force and form that wire the way you want to have it. You place the wire back down into the half-round tube. It's a precision fit, very tight precision fit. A very limited amount of manipulation of this wire can be done on the work model itself. You have to be careful, though, not to break the tooth with the band on it off the work model, not to break that plaster. Also, the loop here, I'll open it slightly to make it fit the pencil outline better. And the loop has been constructed. Now, at the point where the loop begins to turn mesially, you can mark the wire with your wax pencil again. Before you go further, though, it's a good idea to check to be sure that your loop is not impinging on the attached gingiva in this area right here. You have to be sure that the loop is off the tissue, is free of any contact with the tissue in that area. To adjust the loop away from contact, now, there, it has been bent so that it is slightly contacting that tissue. To make the adjustment bend, to remove that contact of the loop with the tissue, you take the wire off the work model once again, and a special kind of bend is made. Impingement of that loop on the attached gingiva is one of the most injurious things that can be resultant from this wire on the patient's mouth. If that loop is digging into the attached gingiva, it can really injure the patient. You place the half-round shaft in the flat base portion of the orthodontic pliers and grasp it. With finger pressure, you simply increase the angulation of the loop to the half-round shaft with a little force. And try it back on the work model once again. And now there is about a millimeter of space separating the loop and the attached gingiva, or the plaster of the work model. Now, when you're satisfied that the first loop is bent the way you want it, as I said, you mark the wire at the point where it turns mesially and begin to construct that anterior portion of the lingual wire. You will find that the wire begins to interfere on the anterior teeth. At this point, you construct that bend by placing the plier beaks just apical to the mark on the wire that you made. And it would be best, I think, to make that right angle bend about 1/3 of the way, and then try it back on your work model to be sure that you're heading in the right direction, to be sure that you've got that bend started at the spot where you want it to be. At this point, you can still move the bend up or down the wire to make it more accurately fit your pencil outline. I think the bend is fairly properly positioned, so we'll complete it. Now, it's impossible to place the wire back down in the half-round shaft or half-round tube at this point because it interferes with the anterior teeth. So at this point, you form the loop portion, the anterior portion of the lingual wire. You can mark the wire at the spot where it begins to curve at about the first bicuspid area there. And with your fingers and the large round portion of the round beak of the plier, right towards the base of the round beak of the plier, you bend curvature into the wire. You can do this by moving the wire along the plier and making a series of very small bends using the large rounded portion of that orthodontic plier. If you want, you can make that bend using just finger pressure too, by using the fingers of one hand as a plier and bending it over the finger pad, the thumb pad. When this has been done, you can try the wire back on your work model. And it won't, I had to put a little extra bend in there to be sure that it didn't interfere. It's a precision fit of that half-round shaft into that half-round tube. And this is the way it should be. For the best results in the mouth, it should be a precision fit. Now, the procedure at this point is to open this wire up through a series of small bends, small adjustment bends, until it contacts in a smooth, continuous curve all of the teeth in the anterior section. Now, the first bend, to make it contact, by simply flexing the wire, you can see that if a bend was made right here, right at this point, the wire could be moved in to contact with the lingual surface of the first bicuspid tooth in that quadrant. So the wire is removed from the work model. And you place the loop in the flat base portion of the pliers, and with some thumb pressure, you apply a little outward force on that wire. And by doing that, you can bring that wire in a buccal direction, and it now contacts the lingual surface of that first bicuspid tooth. The next step is to mark the wire at that contact point with your pencil. You don't want to distort the wire in any way distal to that point of first contact. If the wire is correctly bent to a certain point, no adjustment bend should be made beyond that point, backwards. You don't want to destroy something that you've already created that is proper. The next point of contact that we want is the cuspid tooth. And just by pressing on the wire, you get some feeling of what it would take to bring that wire into contact. I think a bend right at this contact point or slightly mesial to it would help to bring that wire into contact with the cuspid. The curvature is just slightly too large. A little more roundness in that area is needed to bring about the cuspid contact. At a point just mesial to that first contact point on the first bicuspid tooth, you grasp the wire and with some thumb pressure move it in a buccal direction to bring it more towards a contact with the cuspid tooth. The second mark that you made on the wire is the point where you'd like to have the wire contact the cuspid tooth. Since we made a very slight offset bend labially, just mesial to the first bicuspid contact point, you should bring a little curvature into the wire at the point at a point just distal to where you'd like the cuspid contact to be. So right through the point where the cuspid contact should be, or you plan it to be, a curve is bent into the wire, ever so slight. And you try it back on the work model. To check the bends that you've just made. You never go on to a bend farther down the wire until the previous one, the one that you're working on, is just perfect, just the way you want it. Well, there's now a contact relationship of the wire with the cuspid tooth. Now we have a contact on the lingual surface of the first bicuspid and the cuspid. The next step is to bring the wire into contact with the incisor tooth. The same procedure is followed. You mark the wire at the point where you'd like to have the contact be established, and then you remove the wire from the work model, make the adjustment bends, always mesial to the last point of contact that you've established, and in that way bring about the contact of the next tooth down the arch. Something that can take a long period of time. Many adjustment bends are necessary to produce this smooth, sweeping curve in the anterior portion of the lingual wire. We've completed the lengthy procedure of the adaptation of the anterior portion of the lingual wire. The wire is bent so that it's in one smooth, continuous curve, and it's in one plane of space also as it comes around contacting the lingual surface of those anterior teeth. It's a smooth sweep, no sharp bends or sharp corners in the wire as it comes around contacting each one of these anterior teeth. In the second bicuspid region, on the opposite side of the dental arch, the wire is marked at the point where the second loop is to be started. The wire interferes with the half-round tube in this area, so you cannot bend it exactly along your pencil outline. You mark the wire, though, right at the spot where you'd like that second loop to begin. And before you remove that wire, take note of the angulation of the attached gingiva, the plaster portion, to the rest of the wire, to the flat anterior portion of the wire, so you at least have some rough idea of what angle to make that right angle bend to start out the bending of that loop. The wire is removed from the work model, and you place the wire in the plier beaks and make the right angle bend. The portion of the wire that makes up the mesial half of that loop can be measured with a Bowley gauge, just as you did on the other side. It should be about 6 millimeters. This dimension right here should be about 6 millimeters. And you can transfer that measurement to your wire and mark it accordingly at the spot where you want your loop to begin. You place the wire back in the beaks of the plier and start to make the loop. On this side, if you want, you can bend the loop halfway and try it back on the work model, because in extending out the back end of the work model, it won't interfere in any way. and you can see how you're coming along. The loop has been made a little bit, the curved portion, we've started to bend it a little bit too far down the wire. It should start up a little higher, a little closer to that right angle bend. So you can make that adjustment at this point. To do that, you place the wire back in the pliers and you grasp not at the curved portion, but slightly up onto the straight portion of the wire. And with thumb pressure applied as close to the beaks of the plier as you possibly can, you begin to make the curve once the small loop. It takes a lot of force on the pliers to correct that type of bend, because there's not much wire that you're working with, and you end up completing the bending of that loop. You try it back on your work model, and it now fits the pencil outline. This loop was bent so that it is off the tissue at least a millimeter at its point of closest approximation, and it has been constructed that way. Also, the loop should be parallel to the attached gingiva. This loop portion down here, it shouldn't be at an angle like this or like that to that attached gingiva. It should adapt fairly closely so that it doesn't irritate the tongue of the patient. You hold the wire in the desired spot right on your pencil outline, and you then mark it at the point where it should bend distally in a right angle to extend over the occlusal surface of that half-round tube on the molar band. You remove the wire, and start to make that right angle bend. Place your plier beaks just at your pencil mark and make this bend about 1/3 of the way only. And try it back on the model. This is a rather critical right angle bend, as it determines the position of the vertical position of the rest of the wire. It should be bent to rest right on top of that half-round tube. It looks to be going in the right direction. You want to also be sure to bend it so that it will lie directly over the top of that half-round tube also. It should be parallel to the flat portion of the half-round tube. You have to keep that in mind as you're making the bends. Sometimes you have to try the wire back on the model 3 or 4 times, or many more times, depending on how careful you want to be in order to make this bend properly. From this point of view, it has the proper orientation. It lies right on top of that half-round tube. From the occlusal view, it's at more of an angle than I would like to see it. It's not really too bad, but it's at a slight angle. I'd like to see it bent a little bit in this direction here. So I'll make a slight adjustment bend in the wire, and then it will be ready for the soldering of the half-round shaft for attaching this wire into that tube. You make these adjustment bends by putting the whole loop into the flat base portion of the plier, and then using your fingers and thumb to apply the force that's needed to make the bend. Now, it's been bent so that it's now fairly parallel to the flat aspect of that half-round tube. I'll move it out of the way. There you can see the tube opening. You mark the wire directly above the half-round tube. This is the spot where you want to solder on the half-round shaft. Before you remove your wire from the work model, take a look from a back view, from a distal view, at the angulation of this tube to the loop that you've bent. And you can see that it's by no means parallel. So you have to keep that angle in mind when you're positioning that shaft during the soldering process. You can at least estimate roughly the angle that the shaft makes to the loop. In the soldering of this second half-round shaft to the wire, you grasp it in the soldering forceps as near the end of your length of shafts as is possible. And as I said, try to get at least a rough estimate of the angle of the shafts, and the angle of the shaft to the loop that was present in the relationship on the work model. The second half-round shaft has been soldered to the wire and has been placed down in the tube on this molar band. When that is done, the opposite side half-round shaft lies to the distal of that half-round tube on the molar band. It would apply a distal force on this tooth if it was inserted in the half-round tube. We want this appliance to be passive when it's placed in the mouth. In order to pacify the appliance, you place the half-round shaft down into the tube on both sides, and through the use of a flame called a brush flame, about 1.5 inches high, heat is applied to the wire while it's on the work model. You apply heat by moving the flame fairly rapidly around the wire until the wire just begins to turn color. It's a very slight reddish color. This procedure is followed through the entire extent of the wire. It's called heat treating. Even the loop portion of the wire is heated also to remove the stresses. During this procedure, a hand instrument can be used to hold the wire in place on your pencil outline to prevent it from lifting up off the model as the stresses are removed from the wire. Be sure to not heat the wire for too long a period of time in one single spot. Keep the flame moving at all times. You check for passiveness of the wire after the heat treating process by taking a look at the relationship of the half-round shaft to the half-round tube. It should lie just to the lingual and slightly to the distal of the half-round tube if the wire is truly passive. The shaft will slide down into the half-round tube very easily. Very little pressure is needed when the wire is truly passive. This test for passiveness is done on both sides with both half-round tubes. The next step in the construction is to solder on Loctite wires. The Loctite wires are soldered on about 3.5 millimeters distal to the half-round shaft. The distal portion of the lingual wire is bent gingivally, and this is a piece of Loctite wire. It is soldered on at a 90-degree angle to this distal portion, about 3.5 millimeters distal to the half-round shaft. There are two configurations of Loctite wires. The most common configuration is a straight Loctite wire extending mesially underneath the half-round tube to lock the shaft down into the tube and hold the thing in place in the mouth. In this configuration, the Loctite wire is cut off just at the mesial of the half-round tube. The second configuration involves bending a right angle bend, a 90-degree bend in the Loctite wire, so that just the tip of the Loctite wire extends underneath the half-round tube to hold that shaft down in place. In cases where the fridge-gingival margin is in contact with the cervical aspect of this half-round tube, it's less traumatic to the gingival tissues if just the tip of the Loctite wire is interposed in between the free gingival margin and the half-round tube. Very often for clinical cases, spurs are soldered onto these lingual wires. The spur in this case was soldered on to contact the distal surface of that first bicuspid tooth to prevent it from drifting distally while the first permanent molar in this side was moved distally. To solder on spurs, the solder joint is made with the wire at a direct 90-degree angle to the main lingual wire. Usually the spurs are made out of the same size diameter wire as the lingual wire itself. The solder joint is made, and then the wire is adapted so that it extends around to the distal 1/3 of the labial surface of the bicuspid tooth. Auxiliary springs are also soldered on to lingual wires very often to produce minor tooth movements. Here, a spring has been soldered on at the lingual aspect of the second bicuspid tooth, and it extends mesially to contact the first bicuspid lingual surface. These auxiliary springs are soldered on at an angle. The wire is soldered on at an angle of about 10 to 15 degrees, and then it is bent to lie underneath the lingual wire. This angulated solder joint is made so that the solder doesn't flow up the entire length of the wire and thus prevent the spring action from taking place. After you've soldered on the Loctite wires and any spurs or auxiliary springs, the wire is polished with pickling solution first, and then some pumice is rubbed onto the wire with your fingers to remove any deposits, and some rubber wheels. Kratex wheels may be used also in the polishing process. BBC in rouge with bristle brushes can also be used for polishing if you want to have the wire in a very high state of polish, a high shine. The important thing during the polishing procedure is to not distort the wire. It's absolutely necessary that you check for passiveness of the wire before you remove the bands from the work model. These bands are cut off the work model using a lab knife, and they are polished also in preparation for cementation in the mouth. The lingual wire is cemented as one unit in the mouth, that is, with the bands locked to place with the Loctite wires. This is done to be sure that as much passiveness of the wire is transferred from the work model to the mouth, as much passiveness as is possible. For clinical cases, the lingual wire, as I said, can be used in space regaining. And in a case like this one, it can be used to move a mandibular first permanent molar to the distal up to 3 to 4 millimeters to regain space for an impacted bicuspid tooth in a quadrant. The force, the orthodontic force, is applied by making an activation bend in the loop of the lingual wire on the side of the mesially drifted molar. This graphic shows the types of bends that are used to produce this orthodontic force in a distal direction. First, the loop is opened at the curved portion. This produces this configuration of the loop. A second and third compensating bend is made, are made at the right angles of the loop to produce a parallel distal displacement of this half-round shaft from its original position. About 1 millimeter of activation is the desired amount in most cases clinically. The lingual wire appliance can be an extremely useful one in a fairly wide variety of case situations. The exact and accurate construction of the appliance is absolutely necessary if it's to be used successfully. I hope this demonstration has provided you with the information you need to construct the lingual wire appliance properly.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.